The start of a star begins in a cloud of gas and dust. This is also known as the molecular cloud. The cloud consists of hydrogen and carbon monoxide. Under its own gravitational attraction, the gas and dust starts to collapse on itself. As the gas collapses on itself, it begins to heat up. This is where it becomes a protostar. The protostar is basically a collection of the gases forming into a cloud that condenses in on itself due to the gravity formed. While that is happening, it begins the process of nuclear fusion. If the mass is too low to form nuclear fusion, it fails to become a star and becomes a brown dwarf, which is 90% of all stars. Whenever a protostar collapses to the point that nuclear fusion is actually taking place, a star is formed. When there isn't much mass to the star and it's only going from hydrogen to helium, it's called a red dwarf. Red dwarfs are very common and don't give off much light or heat. Since red dwarfs burn through their fuel very slowly, they can live for hundreds of billions of years, technically making them immortal. From a protostar, there are a few paths a star can take. The most common is to become a main sequence star. A main sequence star is formed once matter stops falling into the protostar and it begins letting off heat and light. A star can stay in its main sequence for 10 to 15 billion years depending on how quickly it burns through its hydrogen fuel. The way a main sequence star or any other star burns fuel is turning hydrogen into helium through nuclear fusion. Once there is no more hydrogen, the helium starts to fuse to carbon. The process causes the core to contract and the outer layer to expand and the shine to dull. At that point, the star is called a red giant. The red giant is in its final stage of life. Once the helium runs out and the outer layer is expelled, that is a supernova 1. From there, a planetary nebula is what remains. The core of the red giant becomes a white dwarf, and as it cools and dies, it becomes a black dwarf. Going back to the protostar, it then becomes a blue supergiant. The blue supergiant has the mass of around 20 suns and gives off more light than 60,000 suns. Since it's doing the nuclear fusion slower, the core of the star contracts, making the surface hotter. From the blue supergiant, a red supergiant is formed. A red supergiant is an aging giant star that has consumed its core supply of hydrogen fuel. Helium has accumulated in the core, and hydrogen is now undergoing nuclear fusion in the outer shell. These shells then expand, and the now cooler star takes a red color. Once the supergiant expels the outer shells, a giant explosion forms called a supernova type 2, and then forms a planetary nebula. Back to the red supergiant. At the same time that the shell is being expelled, the core transitions into a white dwarf. As the white dwarf continues to condense, it becomes a neutron star. The neutron star has such a strong gravitational pull it collapses to the point where there is so much matter in a tiny space, it becomes a black hole. Due to the fact that we can't observe these stars up close and personal, our evidence comes from astronomers' highly educated guesses using mad science and math skills.